Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today we're going to talk about an example from past exam. Block A of mass 2m hangs from a cord that passes over a pulley and is connected to block B of mass 3m that is free to move on a frictionless horizontal surface as shown. The pulley is a disc with frictionless bearings having a radius r and a moment of inertia 3mr squared. Block C of mass 4m is on top of block B. The surface between B and C is not frictionless. Shortly after the system is released from rest, block A moves with downward acceleration A, and the blocks on the table move relative to each other. In terms of big mg and A, determine the tension TV in vertical section of the cord. Okay, so basically these two are moving relative to each other, but 3m and 2m, block 2m are moving with the same acceleration A, and this one is rotating without slipping. That means there is a relationship between the angular acceleration and A equals to alpha or A equals R times alpha. We have to find tension in the vertical section, so to find the tension, we use net force equals to ma. So let's consider the forces on 2m. So they are vertical, there is a vertical tension and a downward gravitational force. The net force between these two produce acceleration. So 2mg minus TV equals 2ma. Easily you can figure out TV equals to 2mg minus A. Part B, what is the horizontal tension in this cord? So this tension has one part connects to 3m, the other part connect to the pulley. So ideally you can use either one. So which one do you use depends on what you know. Take a look at 3m. We don't really know the friction between 4m and 3m. We know they are moving relative to each other. We don't know the friction. So there is one extra unknown. But we know because the pulley is rotating without slipping. So we know the acceleration of the pulley. We also know the moment of inertia of the pulley. We know the force in the vertical cord. So the force in the horizontal cord is the only unknown. So that's the one we use. So again, draw a free body diagram. You have two forces producing two torques. Net torque equals I alpha. We're using torque because the pulley is rotating. So net torque is TV is rotating one way and TH is rotating the other way. You have to subtract. TV minus TH times R, that's the torque. Torque equals force times the radius. That equals I, which is 3mr squared times alpha. Alpha is A over R. So from here, we can solve for TH. So as you can see, R cancels. TH is just TV minus 3mr. So you know what TV equals to. When you subtract, that's what you should have. Now, we know we're given that the acceleration is 2 meters per second squared. That's the block A and block B accelerating at 2 meters per second squared. What is the coefficient of kinetic friction between 4m and 3m? So now we can figure out what is the coefficient of friction. We can either use 4m, isolate 4m, or isolate 3m. We don't really know that much about 4m. We know it's moving, we don't know its acceleration, but we know the acceleration of 3m. We know there is no friction between the table and the 3m. We know the horizontal tension, so we know more things for 3m. So we need to investigate forces on 3m. So in the vertical direction, we have a force from the table that's 7 mg. Also, we have gravity that's from Earth, 3 mg. Another force, we know 4m is pressing down on 3m. And that's also called a normal force. Normal force is between surfaces, perpendicular to the surface. So N1 equals 4 mg. Here's N2 from the Earth, N1 is from the block, 4m block. If we have to find the friction, we have to use this N1. So the friction is to the left and horizontal tension to the right. And the friction in this case is mu k times N1. Has to be from block 1. Now let's take a look. Vertical cancels out horizontally. We have net force is horizontal tension minus friction equals to total M times A. And horizontal tension is 2mg minus 5a. We figured out from last part. Here is mu k. Again, we have to use N1 equals to 3ma. So from here, we substitute everything in. As you can see, M cancels out. You find expression for mu k, then you substitute all the numbers. Finally, you have an answer 0.1. Last part, what is acceleration of block C? Block C is 4m. So again, F equals to ma, and let's investigate forces on the 4m. So you have the normal force from 3m that's supporting it, that equals to 4mg, should be equals to balanced gravity from the earth. Again, this friction is to the right. This friction on the 4m is the reaction force of the friction on 3m. The friction on 3m is to the left. Friction on 4m is to the right. Their action-reaction forces have the same magnitude and opposite direction. The friction on the 4m is the one accelerate block C. And friction, we know is mu k times n. N is 4mg, that equals 4ma. So A is just mu kg. We already know what mu k is. We know what g is. So acceleration is about 1 meters per second squared. That's it. I hope it helps. Thanks for watching. See you next time.